In this video I'm going to be looking at the solution to question 3 of the June 2011 Edexcel M1 paper. And this question is on the topic of statics. The question starts by describing the figure 1 diagram. It says a particle of weight W newtons is held in equilibrium on a rough plane inclined by an angle, by a force of 4 newtons. The force is in a vertical plane containing the line of greatest slope of the inclined plane. So these are standard statements in this sort of question. The plane is inclined to the horizontal at an angle alpha, where tan alpha is equal to 3/4. We're told that the coefficient of friction between the particle and the plane is a half, and we're given that the particle is on the point of sliding down the plane. So we're first of all to show that the magnitude of the normal reaction between the particle and the plane is 20 newtons, and also then to find the value of W. I've put that information onto the diagram there, and you can see that we've got the tan alpha is 3/4, mu is equal to a half, the weight W and normal reaction marked in. The frictional force is acting up the plane because it tells us in the question that the particle is about to slide down the plane. So the frictional force is always acting against the motion. The fact that we've got that alpha is equal to 3/4, or tan alpha is equal to 3/4, is a way of giving us the values of sine alpha and cosine alpha. So if we just draw a little right angle triangle with the 3/4 in there, you can see that Pythagoras' theorem, or you probably know that the hypotenuse is 5, and therefore sine alpha is equal to 3/5 and cosine alpha is equal to 4/5. So we were asked to find the magnitude of R and also the value of W. Now it is possible to do this question by resolving along the plane and also then perpendicular to the plane, so in these directions. However, if you do that, both of your equations will end up with W and R in them, the two unknowns. So an easier way is, instead of resolving in those directions, is to resolve horizontally for the first part of the question, because W has got no component in that direction. So if I do that resolving horizontally, we get that 4 and then plus f and cosine of alpha. Let me put the angle in there. Here is alpha in the diagram, so we've got f cos alpha. And then for R, we need the horizontal component. So here's the alpha in the diagram for our right angle triangle with R. So it's the opposite side of the right angle triangle, but it's acting against these, so it's minus R sine alpha. It's in equilibrium, so these forces horizontally must equate to 0. While writing the 4 on the left hand side and taking the others over to the other side, we also need to use the fact that f is mu r and mu is a half, so f is equal to 1/2 of r. So on the right hand side of the equation now we have r sine alpha and minus 1/2, which is r, which is f cosine alpha. Substituting the values for sine alpha and cosine alpha from our triangle, sine alpha is 3/5, so this is r multiplied by 3/5, and then we've got here 1/2 of r, and cosine alpha is equal to 4/5. So you can see that we've got 3/5 r, and then here minus 2/5 r, so this is equal to 1/5 of r. And therefore, multiplying by 5, R is equal to 4 multiplied by 5, which is 20 newtons. So in that way, we've avoided having an equation with W in it. So in the second part of the question we can now resolve vertically, and we can see in the vertical direction we have got r cosine of alpha plus f sine alpha, and that will be equal to w. R is 20, cosine alpha is 4/5. F of course is 1/2 of R, so that's 1/2 multiplied by 20, and sine alpha of 3/5 is equal to W. So you've got 80 over 5, and then here 30 over 5, so a total of 110 over 5, or 22 newtons. Well, the marking for this was to give an M mark and A mark for the resolving in the two directions. There was a B mark for, and that's a mark without method, for getting the values of sine alpha and cosine alpha correct. So these were values which occur within the answer, but if they were seen to be correct, then there were B marks for those two values. Then a method mark and an answer mark, M1 and A1 for getting R, and finally an A mark for getting W. So quite complex, and it does depend exactly where you pick those up, depending which method you use, whether you resolved horizontally and vertically as I've done, or as I say, you could get similar answer of course by resolving along the plane and perpendicular to the plane. Well, that completes the solution to that question. Solutions to other questions can be found at www.furthermaths.org.uk.